Welcome to Pringle Robotics. Today, we are excited to introduce the CC3, our answer to large-scale floor cleaning. Here with more is our robotics engineer, Mohammed.
Hi, I'm Mohammed and I'm the robotics engineer here at Pringle Robotics, and I'm excited to show you today our CC3. This is our industrial autonomous floor cleaning solution that's perfect for hardwood floors, epoxy, and marble in settings such as airports, stadiums, large warehouses, and other industrial settings. This robot has the capability of covering over 20,000 square feet in 1 hour. So let me show you some of the features the CC3 has. First, we'll start with the brushes. There are 2 brushes in the middle of the robot. One rotates counterclockwise while the other one rotates clockwise, allowing us to pick up all the dirt that falls in between. The brushes are a thick brush with large polymer bristles. And on the other side, you can see at the front here, we have 2 side brushes that counter-rotate as well to pick up all the dirt and vacuum it up into the robot. And as you can see on this side is where we have the second brush. So this one would lie directly in here and pick up whatever dirt is in the middle. And we also have a large 1.5 liter dustbin that will pick up any large debris. And when we come to the back side, you can see we have the attachments. So right now the squeegee attachment is put on, and this is mainly for wet surfaces. So whenever some water needs to get picked up and vacuumed up into the robot, this is where the attachment comes in. Or if we just want to dry the floor, we'll use this attachment instead. So this robot comes with LiDAR, 6 ultrasonic sensors, and 2 RGBD cameras on the front and 2 on the back. The LiDAR will be used to map the topography of the robot's environment. The ultrasonic sensors are just to detect if a human is near the object. The robot uses both the RGBD cameras and the LiDAR in order to simultaneously localize and map itself. This allows it to avoid obstacles in real time if they weren't already preset within its topography. On the top of the robot is where you'll find the display and the emergency stop switch. But underneath this hood is where both tanks and the connection ports are housed. The connection ports include USB, Ethernet, CAN, and the bot allows for a SIM card for remote connectivity into the bot. Both tanks, the clean water tank holds 40 liters and the dirty water tank holds 32 liters. Inside the clean water tank is 2 filters. These 2 filters are used to recycle the dirty water into clean water. As for the dirty water tank, a pipe running all the way through the robot will pick up dust and dirt from the bottom and filter it out through here and output dirty water down here. For full autonomy, the robot comes with an automatic docking station. This station will fill the robot up with clean water, charge it, as well as drain out all the dirty water. When the robot is ready to dock, it will use these 2 stickers to guide itself and back up onto the workstation and replenish. With the charging port, the robot will charge in approximately an hour and a half and have a runtime of 4 hours. When the robot is low on battery, it will automatically back up onto the docking station. With the docking station, the maintenance process is fairly easy. The only human interaction that's required is the cleaning of the filters, emptying of the dustbin, and wiping down all the attachments. We'll quickly set up a demo and show you how to map and use the robot. So first, we will head into settings and then create a new map. As you can see, we have 2 maps in here, but we want to make a new one. Let's call it test for now. Confirm. And now it'll give me a blank screen. So all I have to do right now is push the robot around. As you can see, it's already beginning to build up the topography based on what it can see. If I rotate it some more, it'll be able to see more of the room. As you can see, there are some missed lines, so we'll just go ahead and run it all the way through, just so we get every feature within the room. So as you can see, it's already mapping out our route that we took. So if you see, if I turn, these dots, this trail will turn with me, and that's marking our current location. So this should be good enough, so you can stop and save the map. If we had a workstation, we can set it in here, but we'll just edit that later on. So we'll click save. And now let's add some extra features. So we'll go into edit, and as you can see, it says successful, meaning it knows exactly where it is within this current topography. So we'll just set a docking station here, and that's where our current docking station is. So we'll click add, name it, we'll call it start. Now we can add other features such as a virtual fence, prettifier, which just means clean up some of this area, because as you can see right here, there's a lot of junk that we don't need. We can just map that all out and clear it out. For now, let's set a virtual fence. For example, we don't want the robot to go past this line right here. So the robot will never go past this line. We can also add a no-go zone. So if we go into area, we have different type of areas we can block off. Carpet, as the robot can now run on carpet, we have to specify a carpet zone, a speed bump, no-go zone, if an area is sloped or not, or if an area may change over time. Let's say you have a table there now, and later on you won't have a table. So you can set a dynamic area. First, let's set a carpet area, which is what we have right here. Can just draw a square around that. Done. And we'll set test carpet as the name for now. All these can be edited later on. Okay, so we can click save, save. In order to see all the changes we made, we can just view them using this. So as you can see, this right here is doing nothing now. That's meant for a task. So now let's go set a route and a task. First, we back out into settings. We just made a map. Now we make a route. So in our current map test, let's add a route. We have 5 different task types, but for now we'll do drawn polygon, test route. All right. And so I can just drag this, rotate it how I want, and just begin by adding a point here and draw out a whole square or whatever shape I like. So again, we can also see the areas we're not allowed to go into. So here's our no-go zone. Let's, for example, run the robot through the no-go zone and see what happens. And then also let's run it past this virtual fence and see what happens. The robot knows that these areas are blocked off. As you can see, the robot already did all of the calculations and took out those areas we created just to stay outside of those zones. So we have our route. Let's make a new task, create a task. A task is basically an accumulation of multiple routes. So we'll do test task. And now we just added a point where we want the robot to start at or whatnot. So currently we don't have any function points, so let's just set test route, and you'll see it'll populate this area. If we were to add another route, so essentially a different task, we can have the robot clean this area down here after it's done cleaning this area. And so then we can just run it, and you'll see the task pops up.
We're very excited about the CC3, and we know that you will be too. To find out how we can revolutionize your cleaning process, contact us today.